Started. I'll be speaking today about serverless global deployments across CPUs, GPUs, and accelerators, and how we actually leverage the Vultr global infrastructure to do this, to build this technology and this platform. To get started, some context, I'm Jan, I'm the co-founder and CEO of a company called Koyeb. I've spent the last 14 years building cloud infrastructure. Previously, in another life, I've built two IaaS cloud service provider called Outscale and Scaleway. And since 2021, we've been building a platform called Koyeb, and we are providing serverless cloud infrastructure with the help of Vultr. And we'll dive today into how this actually works and how we transform infrastructure full of servers into serverless infrastructure. One key element that I want to highlight, and one of the reasons why we're actually focusing on serverless infrastructure, is that AI requires massive cloud infrastructure. This number is what the AI infrastructure represented at the end of last year in terms of power consumption in the US only. And so we're just getting started with AI, and it's already like nearly 1/3 of the power used in the US. And it's expected to continue growing at this pace. So the projection is that it's going to be multiplied by 6 in the upcoming 4 years. Basically from end of last year, it was nearly 5% of the power used in the US. And in 4 years at this pace, we're expecting it to be using 15% of the overall energy produced in the US, of the overall electricity produced in the US. We see two key challenges. One is that AI infrastructure deployments are completely inefficient. In a lot of cases, the infrastructure which was deployed is underused due to lack of capable software. So if you look at like AI infrastructure in general, there is a key difference compared to traditional infrastructure, is that you want to have the full power of an accelerator when you use it. So if you are buying an NVIDIA GPU or an AMD accelerator or any alternative accelerator, what you want is to use this power, and that's why you have an external card which is added to your server. So the software which we used to leverage before to virtualization is not like adapted to these new challenges. And that's one of the things we're trying to solve with our software and technology at Koyeb. The second key challenge that people face is the complexity and the cost. So most of the organization we meet lack either resources or expertise to actually properly operate their infrastructure. Our vision is that basically AI workloads need serverless capabilities to increase efficiency and to make sure that you don't have so much idling infrastructure. We see serverless as a novel trend in terms of like infrastructure management. If you look back 10, 20 years ago, we were all racking servers. Then virtualization came to markets, and there was an era where in the early 2010s where IaaS was a key way to deploy. Kubernetes came, and we believe that the next generation of infrastructure is serverless. It's progressively going to replace all the infrastructure we use today. So either if you're deploying containers or even databases, there are now serverless databases that you can leverage where the infrastructure adapts to demand automatically. And what we're building is basically a high-performance serverless platform. So we help our end users deploy models and agents and do continuous deployment leveraging containers. And I'll show you how it works in a moment without having to deal with the infrastructure management. So we reduce the cost thanks to the serverless capabilities, and we leverage global infrastructure like the one from Vultr to reduce latency for your end users wherever they are in the world. So what I'm going to do right now, what I'm going to show you is how we deploy serverless containers for both high-performance inference and APIs, thanks to the Koyeb technology. Behind the scenes, that's what our stack looks like. So we have our own serverless orchestration layer, which is letting you deploy either traditional APIs, agentic workflows, which are usually Python software or JavaScript software, and inference engines like VLM, Triton for NVIDIA or other like inference engines. The main primitive we use to deploy is our containers. We have our own technology to do the networking layer on top of the Vultr infrastructure, and we do virtualization on top of a bare metal machine provided by Vultr. At the bottom of the stack, we operate across like multiple providers. So Vultr is one, and then like you might have inside of the Vultr hardware, NVIDIA accelerators, Intel CPUs. We're agnostic, and we provide a consistent experience, as I'll show you now. To deploy across multiple locations, we leverage the capabilities of Vultr. So they have 32 global locations, which we rely on. Depending on the location, we might use CPUs, GPUs, or accelerators, or a mix. So in the case of accelerators, it might be AMD accelerators on top of the Vultr platform. And at the end, what we're providing is a unified and global experience across all of these different kind of hardware. So let's dive in. I'll show you how it works, and what we are going to do together live is we are going to deploy an auto-scaling serverless inference endpoint. So if you're familiar with the space, we are going to deploy a Flux model, which is used to generate images, and it's optimized using a software technology which is made by Puna AI to accelerate the inference speed. And we're going to see how it auto scales together. So if I click here, it's actually like a one-click deployment option where technically it's going to deploy a prepackaged container. And we see that I can hit deploy. And I land on the Koyeb control plane, which is actually like abstracting the underlying infrastructure. That's interesting. Up. Where is? And we lost it. We lost. We lost our control panel, but it doesn't matter. We'll get it back in a moment. Okay. That's interesting. Okay. All right. So that's here. We have it here. All right. So we'll hit deploy, and we are back on this view. We see that we can pick different kinds of hardware. So either traditional NVIDIA GPUs. We can pick across like different regions, Europe or North America, and depending on the kind of hardware, and we can simply actually hit deploy, and we'll get an instance which is up and running using this image. So it's going to take about 1 minute, so we'll not wait together to see what happens, but what we can see already is that it's an instance which is auto-scaling on an L40S NVIDIA GPU, and we will get an endpoint here at the top, which we can query to perform our inference requests. While this is actually like deploying, I have another one which I already deployed. So on this organization, and it's here. So we see that it's actually like the same container. So it's a Puna AI container using the Flux 1 model of Black Forest, running on an L40S, and it's auto-scaling between 1 and 4 instances across all North America, depending on stocks. So if we go at the bottom, we see that it's actually like right now there's only one instance that is running, and we are going together to make it auto scale. So if I go, I make this smaller. I get here. Basically, what we have here is a small script which is making a call on this API endpoint. So we can check it together. It's we see that it's Python. It's performing a call on this .koyeb.app URL, and it's going to generate a file in the output image.pg file. And so if we perform a request, we'll see on the left that it's actually making a call, and we are going to get an image here. Okay, that's the first thing. And so the prompt here was, we can check it together, it was like basically a rabbit jumping in the air to catch a bird. So we have the same thing, so this is simply a Python script. We have the same thing with a web interface. So does anyone want to generate something specifically today? Do you want to see a Vultr maybe? Purple Vultr holding a sign that says global deployments. We can use a faster version of the model, and we will get a Vultr which is saying global deployments. Okay, so that's one thing. We see that it's working, and now what we are going to do together is we are going to make it auto-scale. So I'm going to do a small like Python loop, and I'm going to make a bunch of calls. And what we are going to see on the right, we are going to see the calls stacking up, and we observe the traffic, and every 15 seconds we create additional instances depending on like the number of requests which are queued. So we'll see here new instances starting if we generated enough loads, and we see that it's happening here. So basically what we are doing is we're counting the number of requests. If we have too many requests, we are spawning this new instance to deal with the upcoming traffic. And that's basically what we do on top of the Vultr infrastructure to make it seamless to use the infrastructure. So you can deploy on any of the Vultr location without having to take care of like this orchestration layer. What I just showed you is like two key components and two key sides of our software. One is the scale to zero capabilities. We saw that it's actually auto-sleeping when there is no traffic, and when there is traffic which is coming, it auto-scales horizontally. You can do this with like both inference server and agentic workflow. And at the end of the day, you can actually deploy serverless container for both inference and agents across the 32 global locations of Vultr. And that's it for me today. So if you want to get started with Koyeb and Vultr, we provide like free credits to get started and to leverage our service technology.